So, starting from the point where we stopped last time, previously what we have seen was a, an overview or basically an explanation of real-time products from the data science stream, be it Amazon recommendation or Google Maps we talked about, or the AlphaGo game and other examples which we have talked about. Everything was real time and actually implemented in live. But there were some queries from the guys like, how do we make it? And thus, I'm going to present a case study today. Now, this case study, for disclaimer, is being created by me as part of my capstone project for the master's degree, which I have completed from Great Learning. And as I said, this is prepared by me. It's not been copied from anywhere. The data was extremely raw. We started with a business objective and produced an output. Now, this is being done in real world. And from here, you need to grasp the, or basically link the journey of a data scientist, which we have talked about in the introduction session. And you will be able to relate when we talked about how our project for data science works. In the same fashion, this case study is going to be presented. The another thing which I would like you to focus during the presentation is the time I'm going to spend on a particular thing, be it business study or the case study from the business perspective, the objectives which are required, how much effort is being given to a business objective, how much effort is given to understanding the data, processing the data, pre-processing the data, and how much effort is being given to the modeling or basically doing the coding part. And when we will be going through this presentation, the proportion of time I'm going to spend on a particular section will be approximately in the same proportion where this the time taken for that particular section is being done for the exercise. So this case study is about uh, a lung disease prediction. So this will be here we are gonna predict either a person has got a lung disease or not. And when we go through the presentation, the headings would be like we will going through the executive summary, the business objective of this project, the framework which we have used, the methodology, high level methodology, and the solution framework for this whole of the project. We will talk about the data, what data we have got, how we have processed this data. Then we will talking about the exploratory data analysis to explain the data and the findings out of the data. We will talking about the modeling part where some machine learning models will be shown, and then we'll talk about the conclusion and what is the outcome of the project. So moving forward. So as part of the executive summary, what we're trying to do is this project, which is lung disease prediction, is related to a healthcare domain. And here we know that the healthcare industry is undergoing a rapid transformation and adoption of a new emerging technologies, and population is aging across the world. And internet is bridging the knowledge gap between patients and the physicians. Now, there are a lot of problems globally in the healthcare, which is the kind of like aging population, increasing healthcare costs, limited healthcare resources, gap in preventive healthcare, increasing complexity of chronic diseases conditions. What are the goals? The goals will be for a futuristic healthcare product would be to improve affordability, increase the accessibility, enhance availability of the healthcare, improve the quality of the care. And what are the solutions which one can think about is the strengthening the universal healthcare coverage, building a preventive healthcare ecosystem. Uh, think about the word preventive. So it's talking about predicting something before it's happening so you can prevent it. Improve health awareness and education. Utilize digital health data to predict the early diseases. Healthcare ecosystem. So the ecosystem for the healthcare would span from the health plans, the physician, practitioners, pharmacy, benefit managers, the life sciences, medical devices, prevention, health and wellness, and government health agencies. Now, this is the holistic view of the healthcare domain. Now, what our project is going to touch upon will be building preventive healthcare ecosystem, improving health awareness and education, and also touching upon the data to predict early diseases. And from the ecosystem, we will be touching upon the health plans, physicians, preventive health wellness, and the government health agencies. We As far as the business objectives are concerned, the objective of the project would be to create a lung disease prediction engines for Timor women. Timor is a smaller country, developing nation in near to Indonesia, and we'll be looking at the Timor uh, women's data set and working on to predict the disease, lung disease, for the Timor women's. And as part of the output, we wanted to create some risk assessment scorecard that will support government health agencies, health plan, preventive and wellness programs, and the physician facilities. And if you look at the Timor, it's a small country with 1.3 million population, but you should look at healthcare expenditure per capita is less, which is 100, and 78 physicians per thousand populations is present over there. Now, because this is not a developed country, a lot of um, health is coming from the external expenditure, which is 31%. 31% is coming from the external sources of health expenditure, and the public health expenditure from the government is 90.4%. Only the private health expenditure is only 9.6. So government in Timor wanted to have something where people could live healthy and the expenditure could be brought down for the Timor government. Now, why the lung disease problem? Because this is one of the like fifth topmost cause of the death in Timor. 60% of deaths related to lung disease has increased. So from 2007 to 2017, there's an increase of 60% of death due to lung diseases. Uh, and as part of business solution, we wanted to create risk scorecard for women using the DHS data. So DHS is demographic health survey data, uh, which can help targeted outreach for various population health and prevention program by health agencies such as CISCA or WHO. As part of the framework which we use for the project would be first part would be the data management. So as part of data management, we look at the data quality, data enhancement, integration, and transformation. Then we will talk about you need to relate this part from the last session which we have done is where we have talked about descriptive analysis, diagnostic analysis, predictive and prescriptive analysis. So here next would happen what happened and why it happened, which is descriptive and diagnostic analysis. And then we will talk about what will happen and how we can make it happen, which will be predictive and prescriptive analysis. So we will be basically more touching up till the predictive analysis, and then there will be a small section where we will touching on the prescriptive analysis, how we can prescribe the government to take care of the health condition for the lung diseases. As part of the project methodology, we need to first follow, like this is the methodology which we follow in the project, and this is basically I would say a very standard policy which you have to follow for most of the data science project, where you have to first gather the data, understand it, enrich it, then you will look at the objective and scope. What is our objective? Why are you looking into this data? Data cleaning and transformation, exploratory data analysis, and the exploratory data analysis would be something where you describe the data. So descriptive statistics has to be done for it. The different kind of plots for the data has to be done to understand the how the data is working in relation to the value which we want to find. Then we go with the predictive modeling part, where we create the models for the prediction, and then find out the final conclusion, where we will be concluding and uh, going with the recommendations to the government or the health agencies. No, I'm not going to read all of this because these all sections will be explained in detail later. So high level points are mentioned over here. but we will touch upon these soon. As part of the solution framework, what we use is that from the technology stack, we have gone through the SPSS, Excel, Word document, Tableau, and R. R is a programming language for this project. So we started with the raw data set of women health survey. Now, as I said, this survey was done by a US government, US agency, DHS, which is Demographic Health Survey. They do a very broad and huge survey for most of the countries in the world, and we have contacted them for the data. So they have provided us the data related to Timor women's, where they have done survey of 12,000 plus women in Timor. And the data we will talk about in detail, but it contains a lot of variety of data, a lot of information, and the questions that we asked to the women, and we will be picking up the questions which are important to us and finding out their relationship and making the predictive model based on those. So going with the data management side, so we've got 144 variables, basically 144 factors, if you say, for this prediction. So the factors or the questionnaire relates from demographic information from a woman, her education information, health indicators, of the pregnancy, the health indicator related to smoking or TB, safety parameters, physical activity, socioeconomic activities of the woman. So, so there are a number of variables and the different categories which the data has already got. Then we have done this descriptive analysis where we have talked about the correlation between the variables, different kind of plots, be it univariate or bivariate or multivariate. And then we talked about the predictive analytics which were performed. So again, I want to take you to the previous session where we have produced a diagram and said this is a head of a machine learning, this is right hand or left hand. There we talked about the supervised machine learning. Now, because if you see that the objective is to predict something and predict a person has got a lung disease or not. So it's basically a two-class classification where either person has a disease or not a disease. So yes and no. So this comes under the supervised machine learning, because you will be giving the machine the information of past data that if these are the characteristics, person has got a lung disease, if these are the characteristics, person has not got a lung disease. And that's why, because you're supervising the machine, that becomes the supervised machine learning. And because you're classifying it into yes and no, that's why it's become the classification. And as part of the output, we will be creating some risk scoring, which we'll talk about later. Now, as part of the prescriptive analysis, what we can prescribe would be the lung disease prediction risk scorecard and the recommendation to the agencies who can follow this. So the first step, basically, I would say the biggest chunk for any data science project would be data preparation. Data is the goal for us, and approximately 60 to 70% of the time for a project goes just in data preparation. So when I said that a lot of people on this call, I would say, are very proficient and experienced in data processing, I would say data crunching. So that's why they can make up a very good data scientist, because data scientist majority work is about data, how to understand it and how to process it. So as part of the data preparation, what we have to do is we have got a raw data, which is a women's questionnaire um, data. And this questionnaire contains, as I said, this is about the women's. It contains variety of factors, which is demographic or a health indicator, socioeconomic indicators. As part of the participation for this survey, 12,607 women have participated in this study, and the participants belong to the age group of 15 to 49 years. Participation was done by both rural and urban women. The data which we have got is in the format of SPSS, and it has got 5,300 variables are captured. So basically 12,607 rows and 5,300 columns if you look or imagine it from the spreadsheet point of view. Not every woman was asked all or the similar questions from the survey, and only 1,862 women were surveyed for lung disease related question. And this is our target data set for the study. So when we studied, we instead of studying from the 12,000 records, we have to study only in the 1862 records, because this is this set of the women are the ones who are being asked either they have got a lung disease or not, or therefore the related questions are also asked. As part of the data cleansing, because this data, when I've said, it starts with in the format of SPSS, has got 12,500, 12,000 plus observations, 5,300 variables, and making this working, like what all these variables are, we need to understand from the data what these 5,300 variables are they useful for our study or not. So we need to do some row treatments. In the row treatment, what we have to do is like 12,607 observations were there, but only 1,862 were actually asked they've got a lung disease or not. So this is the target rows which we are actually concerned about. So any observation where the target variable saying up the person has got a lung disease or not, if it's null or the value is not present basically, so we have to remove it. So we treated the rows, and the rows have become to 1,862 out of 1,200 to, sorry, 12,000 rows. Now we need to do some column treatments. So once we go on the learning, or basically without learning, suppose there is a column which has contained all the null values. So there is no value present in any row for that column. That column is of no use. Basically, that's basically a blank column. Or if the column has got all the constant values. For example, if somebody has asked, or basically there's a column which records the gender for the women data set, the gender will be women for everyone, so for every row. So if there's a data which is constant for every person in the past data, or there's a quotient, or basically a variable which have null for all the records for the past data, they will not add anything to your analysis, so you can drop them. So we dropped all the columns, all such columns, and we will be we left with 1,763 variables. So post this, uh, we have to look up if there are some variables which talks about identity of a person. For example, say a roll number, or basically a house number, or something related to the date on which the survey was done. So all such variables are of no use and should not be used as predictors, so they have to be dropped. Any information which is duplicate, for example, a, there's a column of date of birth of a person, and then there's a column of year of birth of a person, month of a birth of a person, and date of birth in DDMMYY. So this is the duplicate information. Using the same information uh, in multiple variables might not be good, and thus they are said to be duplicate information and dropped from the analysis. Then we worked on this 1,663 variables, and we checked if what these variables are. Each variable is being targetedly mapped with the outcome. Now, if there is a variable which talks about the childbirth, or a variable which is talking about the immunization given to the child, the history of immunization of a child, so all such columns are of no use, because our target, or basically the objective of our study, was to predict a lung disease in a woman, and not the study of the child immunization. So such variables are also being dropped. And at the end, we were left with 144 variables to process upon. So basically, we have got this data set which have got 1,862 observation and 144 variables, and now this becomes our target data set on which the further analysis will be done. Now, as part of further analysis, we need to look at the integrity of the data. Is there any corrupt data? And it was found that yes, data was very corrupt, and we have to work upon each of these 144 variables to make them in a proper way, that they are able, like they are able to be passed to the models. By models I mean the algorithm. So algorithm will require data in particular clean format, and that format has to be achieved. uh, No, first part was to define the data types of the variables. So as part of defining the data types of the variables means we looked at the distinct values of the variable, for example, and see, and sorry, like, is it a continuous variable, which is basically it's a numeric variable, integer variable, or a character variable where the classes are there. Then we have to identify the corrupt data. The corrupt data was termed as, if suppose there is a numeric variable. Numeric variable means a number of years a person has lived in this house, and somebody has answered 2 years, 3 years, 10 years, and lot of people have basically answered always. So always is a character, cannot be presented into a numeric column. You have to transform this. So for this transformation, we have to go with the business case study and basically the logic, saying if somebody has said always, what should be the value which should replace the always. Now, I think intuitively you might have guessed, always means the person by birth is living in the house. So by birth means the age of the person. So always has to be replaced by the age of a person. So you need to calculate the age of a person from the date of birth and then populate that age into the places where the always is written. And we basically did it for all the 144 variables. I don't want to go into detail, but for example, I've told you one. As part of the transformation, the corrupt value as per the business case would be, suppose there is a question being asked by a woman, how many childs do you have? So if the women have not been married and thus do not have a child, so basically that value will be null value. Now, the models or the algorithms do not accept the null values, so you need to put something into it. So if the child, like basically when we have received the data, it says null in the number of child because the woman has not been married. So we have to look if the woman has not been married and do not have a child. Basically, that means that the number of childs would be zero. So we have to transform it to zero because it's a numeric variable. We need to identify the missing values. So for example, there's a missing value, like some people have not mentioned, or basically there is no record for the height of a person or a weight of a person. So so we have got the age of that person, and by the correlation we have found it out that okay, height and weight and age, all three are correlated to each other. So if for a record, let's say height is not present, the weight is there, by this correlation we can generate the value of the missing value of the height. Similarly, the missing value of the weight can also be identified. But for example, the hemoglobin level. So hemoglobin level is not being correlated, or we were not able to map hemoglobin level with any other available variable. So for the missing values of the hemoglobin level, we have to impute the missing value by the median of the whole of the data set. Just for an assumption, like we assume that okay, the hemoglobin level is not present, so the median value has been imputed there. Yeah, so the missing value I've just talked about, the identifying the missing value and the treatment for the missing value, because missing values are the holes for the model and we have to fix them. And then we did the one hot encoding. So I don't go into detail of the one hot encoding, but it's just something like uh, if there is an option where uh, it's been asked, okay, a person education, so person could be undergraduate, postgraduate, 12 pass, 10 pass, so four options are there. So when you will learn the models in depth, you will know that uh, the models are conceptually based on mathematics, where something is divided by something. Now if there's an option saying I'm undergraduate, somebody say I'm postgraduate, so these are actually characters, and the model cannot accept the characters. Model need to have a number, so you have to make them numbers by the method called one hot encoding, where we will, instead of one variable, we'll go and say okay, person, education, high school. And if person is have done the high school, we will mark it as one, otherwise we will mark it as zero. Post this, we have to go to the exploratory data analysis. Now exploratory data analysis talks about each of the variable with the target variable. So these are the univariate graphs, bivariate graphs, where we're talking about the color blue is talking about the person who has not got a lung disease, and the orange says the person has got a lung disease. For example, if we talk about frequency of cigarettes versus lung disease, so a person do not smoke, there's a very minute range where they have seen the lung disease. Mostly they do not have the lung disease. With the everyday, you can see 30% persons have got a lung disease who smokes every day. Talking about the chewing tobacco with lung disease, similarly, some important statistics have been found that okay, frequency of cigarettes, tobacco, these all relates to the lung disease. So data is telling a story that yes, these variables are actually related to lung diseases. Talking about chest pain, it's seen that chest pain, only 9 out of 311 people have got chest pain. The person who have got chest pain, only 9 out of 311 have got the lung disease. So chest pain is not a very good factor defining the lung disease. Blood pressure, yes, it is a good factor because 6.5% people have got lung, 6.5 people have got lung disease who have got the high blood pressure. Okay, I don't go in detail of all of them, but yeah, talking about the okay. So here the modeling part comes in. Now, whatever have we have done till now, you see that this is all about stats. So when I said stats is important because until you know the stats, you will not be able to reach up till this point. This this EDA, when I'm presenting it to like only few variables I'm showing, you can see we started from 5,300 variables, we moved to 144 variables, and after 144 variables, I'm only showing you few of these because from the stats we were able to find out which variables actually mean something for the lung disease, and this is what the stats is gonna tell you. So till now, based on stats, we have done the data analysis. Now we are ready with the predictive data modeling, where the coding part will come and see how much coding is required basically. So as part of the coding, when I said okay, coding is required, this could be done either in R, Python, or basically drag and drop. So just I'm not going to go in very much detail of what the data modeling is, but what we are seeing is we are using the data and putting this data into multiple algorithms, and based on this multiple algorithms we are doing something. So basically, if you just imagine, these are the black boxes behind which there is some code, and either you can write this code or you can basically use some tool which will just where you have just have to drag this box and put it here, and once you put it here you will be able to find the final output as in this last green box. This is the final output which says okay, somebody has got a lung disease or somebody has not got a lung disease. And this is talking about some statistical parameters of how good this model is with comparison to the other models. So I don't go in detail in this, but yeah. So conclusion part would be interesting. So conclusion, as part of the conclusion, we have got is from mathematical. So this is not just numbers over here. These are the numbers which we have derived from the past data, and based on this, we have created a risk scorecard where we are just saying that if a person goes and answer these questions, which is either they drink unprotected spring water. If somebody said yes, we drink unprotected spring water, then your risk score for having a lung disease will be 20. Somebody chew tobacco and the 20 is added to their score. So you need to add up the score, and the final score has to be mapped with this risk score definition. So if the total risk score is greater than 75, the person has got a high risk of having a lung disease. If the score is between 40 and 74, it's a medium risk, and if it's less than 40, then you are on a low risk. Now imagine from the government point of view, to find it out a person has got a lung disease or not, a lot of effort has to be done in terms of a survey has to be followed, being from a very lengthy question. So you started with a very lengthy questionnaire of 5300 variables where a lot of question has been asked, and we have drilled down and find out the main key factors, with the points or basically the probability. So these scores are basically related to an odds or probability of a person to have a lung disease. So here you are able to say, okay, this is the factor, and this factor is contributing 20% to increase up the probability of a person to have a lung disease. The chewing tobacco is adding up to another 20%. And once your percentage of the probability is getting increased, then either you are in one of these risk categories. So instead of asking a lot of questions, if the simple survey can be done with only 6 questions where a person can count it on their own finger and could take up the precautions, because this is all talking about the predictive and prescriptive part where you're trying to predict, and person can be prescribed before actually being tested with a long lot of medical expenditure. So here is like what actions could be done or what the recommendations to the agencies would be. So if somebody is asking these questions to you, have you ever been diagnosed with high blood pressure? If you say yes, your 5 points is added, which I just explained. So this presentation is gonna talk about the same. And again, at that, so the output is may seems is very simple, and that's the whole idea of having a data science project is the data might be complex, data might be huge, but at the end there should be something very intuitively with yes no, with some scorecard where you will be able to justify that the output is actually being understandable by the users. You can do a lot of fancy thing behind the curtain, but post the curtain is up, it should be just very simple numbers. So as per the actionable insights, we would say like we will be describing the Timor government or the governing bodies for the health outcome. So the serious consideration and action towards eliminating the consumption of unprotected spring water is required, because we have seen that 20 points are being added for the unprotected spring water. So the regions like Bakau, Amira, and Anau are the first regions which the government should take immediate action upon, because these are the regions which have got unprotected spring water consumers, and thus the government should be looking for the action over here. We need to specialize smoke cessation programs should be built around women, and the areas where the lot of women have been prone to the smoking would be Delhi, Liqua, and Luton. So these are the cities where the most of the women have been found to be smoking. Survey authorities like DHS, we should recommend them that they should start capturing the information about the number of cigarettes, because till now we just have the information from the DHS either person smokes daily or not. So they were not capturing the number of cigarettes. So if we have got the information about the number of cigarettes, then we can actually pinpoint that if this is the quantity of cigarette which should be the max point for on a person education, we can educate them. So start capturing packets of tobacco consumed every day, because the time is left which is less than 1 minute. So I think we have done with the case study now, and post the session, like when we will reconnect, I'll say I will talk about the statistics part. So if somebody is interested in statistics, they can rejoin, and then we will talk about the statistics.